Hi guys! In today's video, we are going to review laws of exponents. There are circumstances where we solve mathematical equations that involves exponents, such as these examples. And to solve this, we need to fully understand what are laws of exponents that we can use so that we can simplify these equations. So for now, what are those? But before we go to the laws of exponents, let us define the parts of an exponential term. So an exponential term consists of two parts. We have b as base, and we have our exponent. So exponent states that how many times you are going to multiply our base. So for example, we have 5 raised to 3. So we are going to multiply 5 3 times. That is 5 times 5 times 5. So we are going to need this in proving some laws of exponents along the way. First one is very easy one. Any number raised to 1 is just equal to the number itself. So x raised to 1 is just equal to x. Example, 6 raised to 1 is equal to 6. 25 raised to 1 is equal to 25. 150 raised to 1 is equal to 150. So this one is very easy. Next one, we have any number raised to 0 is just equal to 1. So that is x raised to 0 is equal to 1. For example, we have 6 raised to 0, that is equal to 1. 25 raised to 0 is equal to 1. And 150 raised to 0 is equal to 1. This one is also easy. Now, let us go to our third law of exponents, which states that if we have two exponential terms with a common base, note, we have a common base, it is just equal to the base raised to the sum of the exponents. Again, if we have two exponential terms with a common base, that is just equal to the base raised to the sum of the exponents. So in this equation, we have x raised to a times x raised to b is equal to x raised to the sum of the exponent, that is a plus b. Some proof, let's say for example, we have x squared times x cubed. We can expand x squared to x times x and x cubed to x times x times x. So as if we determine the product and we can count the number of x's that we are going to multiply, that is 5. So our answer here is x raised to 5, which is just equal to the sum of the exponent. That is 2 plus 3 is equal to 5. Example, 3 raised to 4 times 3 cubed is equal to 3. Raised to 4 plus 3 is equal to 3 raised to 7. Now, our fourth law of exponent. If we have two exponential terms with a common base also, their quotient is just equal to the base raised to the difference of the exponent. So in this case, we have x raised to a divided by x raised to b is equal to x raised to the difference of the exponents. We have a minus b. So proof, let's say for example, we have this one, x cubed divided by x to the fifth, divided by x cubed is equal to x raised to 5 minus 3 is equal to x squared. So to prove, we are going to expand our terms, exponential terms. So in our numerator, we have x to the fifth, so we expand. In our denominator, we have x cubed, so we expand. So we can cancel 3 x's, which is common from the numerator and denominator. So cancel our x's, and what is left is x times x. So the answer is x squared, where 2, our exponent here, is equal to the difference of the exponents. Example, 5 to the 4th divided by 5 squared is equal to 5 raised to 4 minus 2 is equal to 5 squared. Next one, if we have an exponential term raised to another exponent, the answer is just equal to the base times raised sorry, again, if we have exponential term raised to another exponent, the answer is just equal to the base raised to the product of the exponents. So in this case, we have the quantity x raised to a raised to b is equal to x raised to a times b. Proof here, for example, we have x cubed raised to 2. The answer is x raised to 6 from the given law. To prove, let us expand our exponential term. We have x cubed, that is x times x times x, and that is raised to the second power. So we are going to multiply x times x times x to itself, and we arrive at the answer x raised to 6. So example, 2 squared raised to 2 is just equal to 2 raised to 2 times 2 is equal to 2 raised to 4. Next one, if we have a product raised to an exponent that is just equal to raising each term to the given exponent. So let's say, for example, to make it clear, we have x times y raised to a. So it's just equal to x raised to a times y raised to a. Proof, let's say, for example, we have x times y raised to 3. That is just equal to x cubed times y cubed. So proof here, we have xy raised to 3. That is just equal to x times y times x times y times x times y. So rearranging our terms, we arrive at the answer, which is simply we raise each term to the given exponent. Example, 5x raised to 3 is equal to 5 cubed times x cubed, or 125 times x raised to 3. And lastly, if we have a fraction raised to an exponent, that is just equal to raising the numerator and the denominator with the same exponent. In this case, we have x over y raised to the exponent a. That is just equal to x raised to a over y raised to a. So some proof, let's say, for example, we have x over y squared. That is just equal to x squared over y squared. So we are going to expand our exponential term. Our base here is x over y. So we have x over y times x over y is equal to x times x, since we are going to multiply numerator to numerator and denominator to denominator. So we arrive at the same answer, which is x squared over y squared. So example, let's say, for example, we have x over 2 raised to 3. That is just equal to x cubed over 2 cubed, or to simplify, we have x cubed over 8. So that's our last law of exponents. So if you learned something about our video for today, please like our video, and for more content regarding mathematics tutorials, please subscribe to our channel. Thank you.